Welcome to Convergence. Albert Einstein said among the most difficult problems in all of physics is Earth's magnetic field. My name is Michael Doran. I'm a California attorney, and I'm after years of studying this, I argue that Earth's magnetic field is among the most difficult problems in all of biology. Today we're going to talk about sharks, and I think it's pretty common now that sharks not only sense their host, but with magnetic field sensors, but also that they swim and navigate. There's recent studies that show that sharks navigate with the Earth's magnetic field. There's a couple of kind of complex things that I want to talk about, kind of by the way, and then we'll get to the meat of this. The first thing to talk about is the ecology of the shark, and I'm going to try to explain it the best way I can. Imagine you have basically seagrass along a shore, and the fish come there and they eat the seagrass. The way that the ecology would work, if it was just the fish that eat seagrass and the seagrass, eventually the seagrass would be all eaten and the fish would move on, and the remaining seagrass would be selected to be not good for the fish because it's a threat to the fish. And there's no pressure for the fish, for the grass to be nutritious for the fish. So eventually you would get plant lectins and basically poison for the fish. So that whole setup is bad. Now, if you have a shark that comes along and chases the fish away, at least for some of the time, the grass would have a chance to grow back for the fish. But still, there's no selective pressure on the grass to stay nutritious for the fish. Or the fish that consume the grass to be nutritious for the shark. So something's going on there in terms of a selective pressure for the grass to be nutritious, yet to survive, and yet for the fish to be healthy and for the shark that eats the grass to be healthy. And so to me, it comes down to carbonation in the oceans, and the fish and the sharks basically turning the grass into carbonation, the grass turning sunlight and nutrients into grass, and then that grass getting broken down by the fish and ultimately becoming carbonation in the surface of the ocean. And then a surface flow comes along, takes the carbonation, goes into the clouds, and it becomes cloud changing in the context of electrical fields, changes the global electric circuit into a pattern that ultimately modulates the Earth's magnetic field and keeps the Earth safe from space weather or from solar rays, solar weather, and ultimately, and it's dampened, so it's not too big like Saturn and Mars, or Saturn and Jupiter, and not too weak like Mars, where the atmosphere gets stripped away. So it's a modulated or dampened a feedback system that then puts selective pressure on the grass to be nutritious for the fish. It wants to be nutritious for the fish, because if it's not, then basically the magnetic field goes away and conditions much more powerful than the fish or the shark come about that kill all the grass. So predators like the shark actually connect through the fact that they have a magnetic field sense to move and travel and become confused if there's no magnetic field. As they sense the magnetic field, they navigate with it, and they become confused when it changes and there's a lack of it. And that's all the research that's coming about now, and it's all converging and telling us the same thing. Okay, so do I have any proof of this? Well, again, an example of convergence. Paleontologists are going back in time and seeing where magnetic field reversals are occurring in time. And about 19 million years ago, there was a reversal. It's number 6. And at the same time, sharks went in the strata there from being 1 of every 5 fish, so that you have 1 shark per 5 fish, to 1 per 100 fish. It was a shark extinction event that corresponded to a reversal. And these reversals end up being a dampening, because what they're going to do is they're going to change where shark populations are relative to carbonation that goes to the surface of the ocean, and then it's going to change the global electric field, which then is a very finely tuned reaction to the Earth's magnetic field and what it's doing and what the inputs are to the Earth's magnetic field. Another example of this is 2.5 or 6 million years ago, which would be magnetic anomaly number 3, occurred at the same time a shark called a megalodon went extinct. What's a megalodon? It's like the biggest shark ever. Just massive, the size of a bus, like 60 feet long. Giant, 12-foot jaws, that kind of thing. And that type of a shark would have a huge, large-scale effect. First of all, it's scaring fish away from basically a grassy knoll, and then consuming them and removing the threat to a grassy knoll, and doing so again with sensitivity to the Earth's magnetic field. And so it's not surprising maybe if that shark became set with a particular location and prey, and then all of a sudden the field reversed, it could then get confused and disoriented and then not be able to find another hunting ground. But then by the lack of the carbonation and decarbonation in a location, it can act as a feedback to what the Earth's magnetic field is, and then again dampen it and present the proper, as a solution or dampened solution set, the correct solution for where the Earth's magnetic field is. I also want to talk about, and so sharks have been around about 400 million years, and that corresponds to Pangea and Carboniferous. Basically, Carboniferous era had Pangea in the South Pole, and then it started to break up and then become the continents that we know. This period of time there's been reversals all throughout this time, but there's also been a period of time from about, I'd say roughly 118 million years ago to about 80 million years ago, well, 84 million, somewhere in there. And again, this is well documented as textbook science now about when the magnetic field reversed. And so what's really interesting to me about this, and I actually years ago was in a debate with a Ohio State professor as I started to get into this kind of thing. And we were talking specific, his name is Fries, Dr. Fries. We were talking about, just texting back and forth, about the Wilkes landmass concentration. It's on the opposite side of the peninsula in Antarctica. It's basically adjacent to Australia. And this is an anomaly, a gravital anomaly, that Dr. Fries believes is the result of an asteroid impact that was 5 times Chicxulub. So a massive asteroid hit the South Pole, basically. And so when did he date it? Well, he noted that 100 million years ago, you could see that that anomaly was altered by the movement of Australia from Antarctica. So it had to be before 100 million, and just how the rate at which things kind of decay and kind of back to randomness, that he estimated that it couldn't be older than 250 million years. And there's no way to date it because it's under this huge thing of ice. Well, it's perfect in terms of a cause for the Earth's magnetic field to become very stable, because what happens is you have closing isobars with the Earth's magnetic field basically going through that impact site, and that impact site liquefies the rock and makes it more conductive. So it's like almost like creating a wire for the currents to go through that are related to the Earth's magnetic field, electrical currents. The currents and field are related. So you create a magnetic field with currents, and they're related to each other. So if you make a conductive pathway by heating up the rock underneath the glacier and right by the ocean, which is a conductive pathway, you're going to get currents flowing through that impact site, and it's going to cause a place where the Earth's magnetic field becomes really stable over time until that rock cools off. And that's exactly what we had between 120 million years ago or so and 80 million years ago. And that's when bees became community animals about 80 million years ago, and I don't think it's a coincidence. And I also think that this is circumstantial evidence of a dampening, meaning that the dampening acts to cause these reversals, but then you get something significant enough in terms of an input, which is an asteroid impact, then you're going to not have so many reversals, and life isn't still going to act as a dampening, but it's a different way for it to come about. So I covered that. And so I think it's important to talk about what things that you would predict given what we know. So over time, the Earth's magnetic field, I believe, has had to act as a feedback mechanism. And so the biggest factor over time, since life appeared 3.7 billion years ago or whatever, is that the sun has become more luminous. And I believe one of the key reactions by life to this over time is not only to hew the way that the continents are and the way the rivers flow and so forth, but also in the process of doing that, the oceans have become more salty and hence more conductive. And I don't think that's a coincidence, because more conductive pathways will result in more kinetic expressions, which will ultimately cool the Earth from a more luminous sun. So then the question then becomes, well, what happens if we have a glacial and the ice that's in the ocean is removed from the ocean and goes on the land? Well, then, just by that analogy, you would predict that during a glacial it's colder because the oceans become more conductive. And that doesn't mean that CO2 isn't the main agent in feedbacks, or that feedbacks don't occur. In fact, colder oceans hold more carbonation for decarbonation events. But it just is a predictor of why glacials in general, forget about albedo changes and ice on the land. Just the fact that the oceans become more saline is going to result in a colder Earth. And so when you have an impact like the one that occurred in the tropics, as opposed to near the geographical pole, you're not going to have the same reaction to the impact for electrical reasons. Not when an impact occurs, like the Chicxulub impact caused a heating of the oceans about the same as an El Nino. And after a season, the heat from an El Nino is out into space. It's an ongoing thermodynamic thing where the sun is constantly coming into the Earth and bringing heat, and then so much is either reflected away or absorbed. And so it's not such a thing that the impact heats up the Earth and it's there forever. And that's what makes the KT boundary so fascinating, because it resulted in a permanent change in the way climate was. You see it in the sediments, and not only do you see it, but it also, there's evidence that it took 300,000 years before everything over 50 pounds was gone. And I believe that it's almost like if you took a knife into a computer, it's not so much the thermodynamic effect, but it's the fact that you've destroyed the computer. And likewise, if you have an impact in a place on Earth where there's a lot of life, which is in the tropics, you're going to damage the computer, the intelligent design, the quantum brain, a large part of the quantum brain of a living Earth. And understand that when nucleotides were in clouds and early life was evolving, it was just nucleotides and clouds, maybe some carbon dioxide, but mostly nucleotides, where they could be both a model and a feedback. This is a massively parallel type of calculation. And so when I talk about how since life began and nucleotides moved from the clouds and into cells and into the biosphere and out of clouds, that there remained a massively parallel part to it. So it's not just the intelligence of a shark, but I think as a prime predator, top predator, like the shark was and is, it's a major influence on carbonation and where it is. But it's still part of many different life forms that are acting intelligently and massively parallel to affect the Earth's magnetic field and to dampen it. And I can't overemphasize this enough, particularly since I'm not the only one on the internet, on YouTube, saying we're going to have to start looking at the Earth's magnetic field, and we are. But those people who are looking at the Earth's magnetic field and seeing, oh my gosh, there's these random inputs, these crazy inputs from space, and wow, they're having this huge effect, and it could be cumulative, and it could really change climate completely. And not understanding that the math behind it is not chaotic, but rather is dampened. It's a dampened oscillator, meaning that we expect these things to come in, and life over huge timescales has evolved feedbacks to keep the climate and the Earth's magnetic field steady. And one of the principal things, I think, from the Chicxulub impact we saw is a reduction of oxygen in the atmosphere. And that then results in anything that's larger having a difficulty. And I think that's why anything over 50 pounds, about 300,000 years later, this is all textbook stuff, was gone. We get birds, which again migrate. They're tiny, they migrate to maybe where there's some greener pastures, and they use Earth's magnetic field. They get confused if the field is changing, and they survive. So that's the part of the dinosaurs that lives, and that's the part of the quantum brain that continued. As things have continued to change, and Earth it continues to experience an ever luminous sun, and our star, our planet, has had to change as well in terms of the feedbacks. And you get cold-blooded life giving way to warm-blooded life. And I think that's because the dampening has had to go to colder places, and life has had to move a little bit more out of the tropics and do its carbonation thing. And it's an advantage to have warm blood. And we're now in a period of time where humans are the top predator. And are we going to act like shepherds, or are we going to destroy the planet? And I think it's a real question. And the big thing that I'd like to do is change the way biology is thought of and to educate the public. Well, I appreciate your time. Please hit like, please subscribe, and have a good one. Thank you.